In this video, we will discuss about the different types of charge distribution. The topic is going to be continuous charge distribution. So in this continuous charge distribution, there are three types of charge distributions that we are going to see. One is called linear charge distribution. The second is called surface or areal charge distribution, and the third type is called as volume charge distribution. So before we get into these kinds of charge distribution, let's try to understand what we were trying to do till now. So till now, if you see, all the topics that we discussed were concentrated only upon the type of charge called as point charge. So what do you mean by a point charge? Point charge is also called as a particle charge. So a charge which does not have a finite shape associated with itself is what is called as a point charge, right? Now the counterpart of point charge that we are going to see is called as an extended charge. So let's try to understand what an extended charge is. So as the name suggests, extended charges are the ones which have a finite shape associated with it, finite shape and a size associated with them. See, for example, if I talk about this marker, if you take this marker, if you are able to give a charge to this marker, can I call this marker as a point charge? Obviously no, because there is some finite length associated with this particular marker. It has a particular cross-sectional area and it has a volume as such. So it has a finite dimension associated with it, right? So in this topic, what we are going to mainly concentrate is on the type of charges which are called as extended charges. In those extended charges, these are the three main types of charge distributions that we are going to discuss. So as the name suggests, linear charge distribution means if you are able to take a one-dimensional shape, on this one-dimensional shape, if there is charge distributed on top of it, then this type of a charge distribution is what is called as linear charge distribution. To put it in very simple terms, one-dimensional charge distribution is what is called as linear charge distribution. Similarly, we can think of a two-dimensional shape. For example, let's consider this whiteboard. If you are able to deposit charge throughout this whiteboard, then you can say all those charges are distributed over the surface of this whiteboard. So such type of a charge distribution is called as surface charge distribution. So for surface charge distribution, you need to consider a two-dimensional shape. And the last type is volume charge distribution. Volume is something associated with a three-dimensional shape. So if you are able to take a three-dimensional shaped object and in this, if you are able to completely fill it with charges, so if the complete volume is filled with charges, then this type of a charge distribution is what we call it as volume charge distribution. So the next topic that we are going to see, the next subtopic within this is going to be the type of density that we can define. See, if you speak about a point charge, the only parameter that you need, maybe two parameters that you need to know about them is what is the nature of the point charge, whether it is going to be a positive charge or a negative charge, and the second is about the magnitude of the charge that it has. Now here what happens is, in the charge distribution which is not going to be a point charge, that is when you have an extended charge, in addition to the parameter charge, you also need to know the charge is distributed over what parameter of the dimension. In the sense, if I talk about linear charge distribution, let's say this material has a total length of L and sum of all these point charges put together, if I call it as Q, then here we will not be concerned about the total charge on the material, rather we will be concerned about how much charge is distributed over a given length. Suppose I take a small piece of suppose I take only this particular piece. So our interest might be how much charge is distributed over this length. So what is that you are going to define is called as density. Okay. So the type of density that you are going to define for a linear charge distribution is called as linear charge density. So what is linear charge density? It is represented with symbol lambda. It is defined as the amount of charge distributed over unit length. So if you are able to define this parameter, that is called as linear charge density. Similarly, for a two-dimensional shape, the type of charge density we are going to define is surface charge density. So what does surface charge density mean? It is the amount of charge that is distributed over a given area A. Now for volume, what we will do is we will define volume charge density. We will define volume charge density, and volume charge density is represented with the symbol rho. It is defined as the amount of charge distributed over the unit volume. So if you look at this, it is the amount of charge per unit length, means one dimensional. Amount of charge per unit area, it is two dimensional. Amount of charge per unit area, it is three dimensional. So what is going to be the SI unit here? The SI unit here will be Coulomb per meter. The SI unit here will be Coulomb per meter square. The SI unit here, it will be Coulomb per meter cube. So this is all about the types of charge distributions.